Hello everyone, welcome to the video. Today we're going to talk about the PFMEA in the manufacturing process. At the any manufacturing process, always going to be risks, and the risk could be building defective parts, quality issues, warranty issues, and also safety concerns. So the PFMEA is the method that we use to capture those failures and create precaution to prevent them from happening. So today we're going to talk about the PFMEA, the document of the PFMEA, and then we talk about example of one process, a manufacturing process. The PFMEA stands for a process failure mode and effects analysis. The document of the PFMEA will look like this. First thing in the column shows that it's a process that could be a certain dimension or certain requirements for the customer, potential failure modes, which means that what could go wrong when we run this process or on at this process, potential failure effect that's going to be on the customer. The severity is like from it's a ranking from 1 to 10. The severity is how severe is this failure at the customer. Potential causes, that could be what was the cause. Potential causes, and then the occurrence, that's a ranking from 1 to 10. And current controls, that's what's the detection that we have in the current process, and the detection ranking is 1 for 10. RPN is the risk priority number, which is the multiplication, so multiplying the severity, occurrence, and detection. So the way we can address the severity is based on the severity chart. So normally when it's high number means it's higher severe situation. So normally 10 and 9 and 10 severity is always something that related safety. The safety for the employee, safety for and the customer end, anything that's going to be like dangerous, that affecting people, and so on. That description for this is a description for each rank value. Same thing applies for occurrence. This is the chart for occurrence. That's how likely this failure could happen, like 1 for every 1 million. Detection is when I have high detection, I have low number, means that the the uh, the system is can detect, or the process can detect this failure effectively. When I have high number, we don't have a good detection. So we can use an example using Flexum. So a very basic example, which is I have an operator, I have a machine. Operator is actually doing packing, 8 boxes, green boxes in the skid. So that's a requirement. Each skid should have uh, 8 boxes. So when he's done packing 8, he's going to go to the label printer, pick up a label, place it on the skid. The high-low comes in, pick up the skid, and take it to the warehouse. So applying a label right here, we have a high-low going to comes in. So we're going to pause and go to the example we have in the spreadsheet. So the process here, that's a requirement. We said that's going to be the pack 8 parts per skid. Now we have a third mode that could be overpacking or less packing. So we could overpack 8, maybe we could put more than 8 or less than 8. The effect, that's going to be shipping interruption, that we could overship parts to customer, causing going to have, or we short ship parts. For that reason, that could interrupt their production on their shipping. So that's why, based on the ranking, we put 7. Potential cause is operator error, just normal human error. Occurrence, since everything is going to be visual, there's no automation, that's going to be 5. Control is visual inspection. We just like visually see that was anything is wrong. Detection is always going to be 7 because it's manual, it's visually. So the RPN, we have high RPN, 245. So it depends on the industry, depends on the customer requirements. So we have in this case 245, consider high. A certain customer or guideline they requested like has to be less than 150 or less than 100. Let's consider this is high RPN. When I have a high RPN means that the system is not robust, which means that I'm gonna have customer complaint from shipping, overpacking parts or less packing parts in this. We created an action requirement. months, we have to introducing some kind of automation in the packing process. What we're gonna do is we're gonna link the label printer to the machine finished goods and do the count, automatically count 8 parts. So whatever we have finished good 8 parts, the label printer is going to be automatically print labels, like one label at a time, as an indication that 8 parts it's been produced and it's been packed. And the operator that way going to take it, apply it on the skid. That's responsible. It'll be myself, Mustafa. Action taken. That's just a quick summary. That was the action that was taken. So that's an action plan we created, and that way we use that to reduce the RPM. So the severity is going to stay the same. Occurrence is going to change because we introduce automation, and detection is going to change because that way if I pack 9 parts in this kit, the machine is going to stop, and detection is going to increase because it's automation based on the detection chart. So multiplying that, our new RPM becomes 84. If I keep run this uh, example, so the printer is going to be automatically print one label at a time whenever I have 8 parts finished. That way the operator is going to check and say, okay, I have one label printed means I already packed 8 parts. So that way that we actually can avoid packing quantity issues. That's all I have for today. Thank you for watching, and I will talk to you later.